Howdy, it's Tubalcain again. Today's video is going to be in regards to making a test bar for tailstock alignment on the lathe, and I know I've beaten the heck out of this subject. I've just beat it to death, but by popular demand here we're going to show you how to make a test bar, and that's the subject of this video. Not how to use the test bar. That's shown in one of my other videos. I forgot what the number is, but look it up. I have a directory on there to help you find some of the videos, because there's about 200 of them in all. But here's one that I made and I used in the video. It's 3/4 inch drill rod, which is tool steel, and we've got a center hole on each end. Now that looks real simple, like just face the ends, put it in any old lathe and center drill it and you're done. But it's not going to be accurate enough, and I'm going to show you why as we progress through this. But you need to use drill rod. And by the way, these cost $70 or $100 if you buy one off of eBay, and it's they're usually ground stock like this. And I noticed that in some of them they're using Thompson's pre-ground stock, which is quite expensive. It's of the highest quality, but a drill rod again is tool steel, and the piece that I got, I don't even know where I got it, but I had several pieces and they're still in cardboard, and this was for some reason 3/4 inch by 20 inches. I don't know what the purpose of this was, but I had a whole bunch of it in different sizes. But drill rod is going to be pretty darn straight, and it's going to be very consistent in diameter because it has been ground probably on a centerless grinder. But this is 3/4, and what you want to do is double check that it is the same diameter throughout its length. And I'm checking it in 4 or 5 spots, and in each case it's just a little bit less than 3/4. Now we're also going to check to see if it's, so we know it's round, we know it's consistent in diameter, and we want to make sure that it's straight, so we're going to roll it on my surface plate here in a moment. I would say do not attempt to do this with cold rolled steel or just common steel that you're going to find in any stock rack, because it is probably not accurate enough. You can try it, but I'm recommending using drill rod. This is 3/4. You probably could use, I made one out of 1 inch also, which is nice, but I wouldn't go any smaller than say 5/8, but 3/4 probably would be ideal diameter to use. Your test bar doesn't need to be this long. This is 12 inches. You probably could settle for about 8 inches or 10 inches, but the one I'm going to make now is also 12. Actually, it's a little bit longer than that, but I don't want to cut it off, so I'm simply going to make it a test bar as it is. But what you want to do, if you have a nice granite surface plate like this, wipe the plate off real good. You can even clean these with water, because of course they're not going to rust. And make sure that your bar is clean. And I'm putting a little light, LED light, at the back here. And then I'm getting down on my knees and I'm looking here to see if I see light as I roll it. And I've already done that, and it's very true, or about as true as you can possibly expect. Now, so the commercial ones, that at least the one we had when I was teaching high school, was made by some shop where it was made on a large Landis or Cincinnati cylindrical grinder, which could be counted on, with a large wheel. And but you're not going to be able to grind one of these on the lathe, a little do-more grinder or anything like that. So that's why I'm suggesting you start with a high quality 3/4 inch drill rod. I will now face both ends. Now I'm going to chamfer. other side of this tool. I'll do that both ends. By the way, we're working on the 12-inch closing lathe now, but any lathe will do. I'm going to use a number 5 center drill, which is kind of a large one, and center drill both ends, and I like to drill about 2/3 of the way up the tapered part. Slow to your work so that the point tries to find the center. Remember, these center holes are just rough. We're going to bore them. This steel is very tough. You can tell that it's tool steel, so we need plenty of cutting fluid. The finish that we were getting was not all that good, but it's just fine. We're only facing the ends. It really doesn't matter at all. You don't want to break the end of the center drill off, or you got to throw the work away or cut the end off. I stepped over to the 12-inch Craftsman Atlas lathe, and you know, some of you are probably thinking, well, the job is done, and you know what, maybe it is. We got it center drilled on both ends, and we've got nice round true stock that's straight, and in fact maybe we are done, but we're going to double check, because I would say there's about 1 in 10 million chances that it is ready to go just as is. But we're going to put it between centers and proof it here and see if we need to go to the next step, which I believe we will. Alright, I've put headstock center in and a tailstock center. Now again, like I showed you in the other video, make very sure that everything is clean when you assemble that, or all is for naught. And we'll put this between centers. Just tight enough so that we can rotate it. And let's take a look at the indicator. You can use any kind of indicator you want, the magnetic base or last word, whatever you happen to have. I like this little setup that I've got here. I showed it in another video because it's unobtrusive, and the magnet doesn't get chips and all of that crazy business. So if I can zoom in a little bit on the indicator now, and remember we got parallax going here. I set that at 0, but it doesn't look like 0. Now, let me explain what parallax is in case you don't know what I'm talking about. But remember when you were a little kid, you'd look at the speedometer from the passenger side and say, "Hey, Dad, you're speeding." He said, "No, I'm not." And you're there, "Yes, you are. It says 70. And he said, "No, I'm going 60 or 65. He said, "You're looking at it at an angle." And then when you get over next to your dad, you can look straight down, and sure enough, he was not lying. Alright, enough of that sidebar. Let's see what we got. Bring this in. And I'm rotating this now. And you can see that I'm off. Oh, it looks like about 5 thousandths or so. Maybe not quite that much. And the same is probably true on the other end. I'm going to check that too, but I'm not going to show it. So this is not satisfactory. We must go to the next step. I'm over at my little half lathe now, my little hardened speed lathe, which I dearly love, and it's highly precision. Now I know that most of you out there in Radio Land will not have 2 or 3 or 4 lathes to switch back and forth to, such as what I'm doing here. But ideally, it would be nice if you have a lathe with a 5C collet attachment. So these are 5C collets. If you have 3Cs in a smaller lathe, they will not accommodate the 3/4 inch diameter. So this is the ideal setup. However, this can be done with a 4-jaw chuck in any lathe that you have that has a 4-jaw, but you must set it up so it's absolutely on zero. So if you're not adept at that, this may be where you'll have to quit, but you need to be right on the nostril. Now I had 3 3/4 inch 5C collets, and I put one in there and I indicated the work, and it was about 2/1000ths off. And then I put the next one in, and that was off, I think 1/1000th. And finally I had a third one, which I happened to find in my spin index, and I put that in there, and it's right on. I really thought that all 5C collets were accurate, and maybe they were, because everything I have is used, but these either were worn or whatever, but they are not accurate and not usable. So I'm going to put the work now in this 5C collet, and we'll put the indicator on and see what we got. Alright, take a look at this setup. I've got my little Starrett magnetic base down there on the bed, and the last word indicator on the other end. And I have only about a 1/2 inch of the work sticking out of the 5C collet. You absolutely don't want any more sticking out than necessary. And then we're ready to rotate the work and see what how far we are off, how much runout we have. So I'll position the camera, if I can, straight over that indicator. The camera is overhead, and notice how the tip is touching the work of the last word indicator. Zoom in just a little bit here, and I've got it pretty well on zero. Now I'm rotating the spindle with my left hand, and you can see the needle is moving possibly 1/4. Those are 1/1000th the graduation, so possibly about 1/4 of a 1/1000th I'm off, and I would like it to be perfect, but I'd have to say that's pretty darn good without laboratory type machines and laboratory conditions. The Hardinge lathe is an accurate lathe. They're noted for their accurate spindles, so any error that I do have here could possibly be a minor problem with the stock itself, or maybe a little rust on the stock, or a collet, probably something to do with the collet. Remember, 1/4 of a 1/1000th is less than 1/4 the diameter of a human hair, or 1/4 the thickness of a cigarette paper, so we're pretty darn close. We are now ready to bore that hole, and that's what this is all about. I hope I made it abundantly clear why we're doing this. Now that we have this set up accurately, what I'm going to do is to bore the center hole. The center hole, it really was just roughly formed, and we can't start boring without a hole that's already there, so we're going to basically true up the center hole and bring it so it has absolute concentricity with the outside diameter. Now if we were to put the indicator tip in there and touch the center hole and rotate the spindle, we would also see that it would be off because it is not concentric. And it just can't be by center drilling in a 3-jaw chuck like I showed you on the closing a little while ago. It never is. It's fairly close. It might be within 2, 3, 4/1000ths, depending on how accurately you drilled and how accurate your chuck was. And we know those older chucks aren't very accurate, so we're going to bore this out. Now I'm going to take a Sharpie marker off camera, and I'm going to blacken the inside of this hole so that as I bore it, I can tell when it starts cleaning up. I love this little Hardinge lathe, but if you don't have one, and you probably don't, this can be done on other machines too. But I've set the compound for 30 degrees, and this is the cutest little thing on a Hardinge lathe, that there's a little magnifying glass built in here. and I've got it set on 30, but that's not going to show up on the camera. And then you can even shut this with a little door to protect it. So they went to great care, and that's why these lathes cost so doggone much. Now you're going to have to grind the little tool, because you're not going to find a commercial boring bar, I don't think, that is this small. So that's just a 1/4 inch high-speed steel that I have ground rather crudely, but yet effectively, into a mini boring bar with all of the angles that we've discussed in my other videos. And just the very tip there is what's going to touch, and I'm going to feed in like this at an angle, at a 30-degree angle, and clean that up. And I have blackened that hole as just mentioned before. And here we go. And I'm feeding the compound in by hand. So we've got that pilot hole in there in the middle that a center drill produces, and that's kind of like a little reservoir for my chips, or I should say a place to terminate this cut without bottoming out. And I can see that I'm starting to clean it up. You see that blacking that is gone. And now I've cleaned that one up. No, I think I need one more pass. 2 thousandths more. And that one's doing it, the blacking is gone. And I'll do the other end the same. I am now indicating the center hole that was just rough drilled. This has not been bored yet. And you're going to see that this will be quite off when I start rotating the spindle. Something in the neighborhood of 5 or 6 thousandths off. So a center hole that's been rough drilled in a 3-jaw chuck is never very accurate. And that's what I am demonstrating right here. I might be overdoing this a bit, but now I've got the last word indicator in the freshly bored hole. And we'll take a measurement there, and the whole idea here is concentricity, so we want this to be truly concentric with the outside diameter. And really we know it's going to be. I mean, it's a given in that I bored it. But look at how nice the surface finish looks in there with that little tool that I made. Okay, I'm rotating the spindle. You can't tell it. You're going to have to take my word for it, but you can see that there is no run out at all. This is the final pass on the second end. What we're really doing here is boring, and for that matter, turning a taper by the compound rest method and boring at the same time. You see how that blacking in there, or bluing, whatever you use, it helps you see that you're truly cleaning it up. Now we'll put it between centers and see if it runs true. We're back in the Atlas lathe between the centers, and it's really running very true. Now do not watch when I wiggle this. There's that much flex in the lathe or the work. I'm not turning it, I'm pushing and pulling on the center of the work. That's how much 3/4 stock flexes, you know, 3/4 thousandths just by me putting 50 pounds of pressure on it. But so I don't want that to influence it, because I'm as I rotate this with my wrist, I'm also, I know, pushing a little bit one way or the other. But we're running virtually on zero there. I am turning it now. I don't know if you can tell, but now I'll do the same thing on the tailstock end. We're at the tailstock end. You can see how much I can make it fluctuate here. Alright, now I'm rotating it, and there is virtual run out on that end. And while I was at it, as I cranked this from one end to the other, I was taking a check, and my tailstock is in alignment, because I had done that on a couple of videos ago. So all is okay with this lathe and the test bar that we just made. That's the suggestion. Remember, start with high quality tool steel that is accurately ground and is straight, and then bore your holes accurately, and you will have yourself a test bar for 10 or 20 bucks. This is Tubalcain saying so long for now.